Welcome to another video, everyone. Today we're going to be talking about our first method of solving differential equations. And this method is called separation of variables. So you'll find that this is the easiest method, which is why we're starting off with it, but it will also help you just kind of solidify these concepts of solving diff-EQs, what it means, and just kind of build intuition. So separation of variables is a method by which we solve differential equations. And so how do you know if you can use separation of variables? Well, that's a good question that you ask. If the differential equation can be written in the following form, dy dx equals some function f of x and some function g of y, then we know that the function is a separable, or the differential equation is a separable equation, and we can apply this separation of variables. Equivalently, if it takes this form, because what we can do is just divide both sides through by dx. That doesn't happen. And then we divide also then that by m of y, and we end up getting dy dx, which I think we did that in a previous video. But you'll get this ratio between m and x being the derivative with respect to the independent variable. So either of these two forms, that lets you know that the first order differential equation is separable. And so, for example, let's just kind of do a quick little thing here. So let's say that dy dx equals x 1 plus y squared, right? So what we want to do is get all of the x's on one side with the dx and all of the y's on one side with the dy. You can see right here that I can multiply through by this dx, and then I can divide through by this expression in y to basically put them on the opposite side of the equation. So I'm just going to do that all in one step right now. And then you look at these expressions on each side of the equation, and you're probably thinking, this looks like an integrand, but there's no integral symbols. Well, luckily for us, the integral is a linear operator, and so we can apply it to each side of the equation. And by integrating, we can actually solve this diff-EQ. So let's do that. Knowing our trig identities, we should be able to recognize fairly quickly that the first integral is equal to the inverse tangent of y. And then if we just use our power rule for integration, we end up getting 1/2 x squared. And then don't forget the constant of integration. There are no bounds specified, so this is what we call indefinite integral. And so they involve this constant c to compensate for the fact that we don't have any bounds. Let's solve for y. That's what really we want to do, because that's going to be the function that solves our differential equation by just taking the tangent of each side, right? If you remember from your trigonometry or pre-calculus or calculus. And so this function is going to be the thing that solves this differential equation. And it's pretty easy. So basically, the general steps that we took here. So like I said, we started off with some dy dx equals f of x g of y. And separating the variables gave us this 1 over gy dy equals f of x dx, and then we just integrate the thing, and then that's essentially the general steps that we took. So let's just do a quick example. I'll make it really basic since this is one of the first ones that we'll be doing. And so once I write this down, just pause the video and start solving it on your own. Should take you no more than 2 minutes, I would say. And then I'm just going to jump into it right now. So separating the variables, I'll do this one step at a time. What I'm going to do first is I'm going to multiply through by dx on both sides of the equation, getting dy by itself, right? So we have dy, the equation is dy dx equals 3y, and we have 3xy dx. Let's now divide through by the y on both sides of the equation to get 1 over y times dy equals 3x dx. The next step should be obvious, recognizing that we have expressions that look like they belong in the integrand. So let's just integrate both sides of this equation since the integral is a linear operator. And then from our integration tables, we should have by now memorized that the integral of 1 over y is ln of y, and then using the power rule of integration, we get 3 divided by 2 times x squared, and then don't forget your constant of integration. Again, indefinite integrals. How do we get rid of this ln? We need to get y by itself. Well, we can just take Euler's number as the base of each side of these equations. From algebra, we know that Euler's number cancels out with the natural log, and we're just left with this expression on this side. So recasting this whole equation, we'll get y equals e to the 3 over 2 x squared plus c. That's all in the power. So let's rewrite this addition in the power as just another, we'll write it as 2 exponential functions. And then this is just another constant. So we can just call that c as well. And we say that y equals c times e to the 3/2 x squared. And that will be the function that solves this differential equation here. And so I think that was a pretty thorough introduction to separation of variables. I'm going to wrap the video up here. If you would like me to clarify anything, please just leave it in the comments below. And also, if there's anything that you would like me to cover in the future, also do the same. So I hope that helped, and have a great rest of your day.